we are looking at propositional logic. When we talk of logic, basically, we are looking at the uses of logic. Logic is used to distinguish between valid and invalid mathematical argument. And this logic topic was first developed by Aristotle. It has a lot of applications, especially in the area of computer science. When you talk of design computer circuits, when you talk of construction of computer programs, when we talk of verification of correctness of computer program, these are all an application of logic. So logic is a system-based, and it is based on proposition. So that's basically what logic is. Now, when we talk of proposition, we are talking of declarative statements, which either can be true or false, but not both. A declarative statement which either can be true or false, but not both. So, example, talking of declarative statement, Dr. Jivon is a lecturer in Accra Technical University. Could it be true or false?
True.
So it could be true or it could be false, depending on which Dr. Jivon you are looking at. So that is what we call a proposition. Proposition is such a declarative statement. Is that okay? So who can mention some propositions that we think of? A declarative statement. That's the outcome could be true or false. When we talk of statement, we are talking of sentences that have a full stop at the end, which outcome can be true or false. Yes, so let's listen to Bernard Monte.
All right, sir. My name is Bernard. So one example I can give is, I am a woman.
Okay, so I am a woman. So what are the possible responses?
It's either true or false.
It's either true or false. Okay.
Yes, sir.
So it doesn't matter whether you know the answer is true or whether you know the answer is false. What matters is the statement mentioned will be either true or false. Is that okay? So don't think of knowing the basis of the statement. All right. So, Frank, can you talk and mute yourself? Talk first, then you can mute yourself. So Frank has just logged on. He's not in class, and yet his microphone are disturbing everybody. Rosalie,
Sir.
Please give us a declarative statement that could either be true or false. Give us a proposition, yeah.
I can say, let's say, Mahama is the president of Ghana.
Good. Mahama is the president of Ghana. So what are the possible outcomes? True or false, right?
Yes, true or false.
Okay. Yeah, all right. So that is proposition. So I hope you understand what proposition is. Okay.
Yes, please.
All right. So when we are talking of logic propositions, we always use letters to denote their symbolisms. So we can use any letter, but must be defined. For example, you can use P, Q, R, X to denote the simple statements that form the declarative statement. Okay. All right. So
recording in progress.
All right. So we can continue, right?
Yes.
Mathematical logic is a tool for working with complicated compound statements. Okay, so when we talk of compound statements, we are talking of combining one or two or more statements together to form a particular statement. So mathematical logic is used in doing such. Okay. And the reason is it has its own methodology. So a methodology, mathematical logic is a methodology for objective reasoning about the force, the truism, and the falsity of the statement. So when we talk about propositional, now this is what I'm going to do. I can mute you in such a way that you cannot unmute yourself. All that you do is to listen. Is that what you want? All right. So when forming a compound statement, we use connectives to connect compounds, a simple statement to get a compound statement. We use connective to do so. So for example, the connective that I use are called the Boolean connectives. So we use Boolean connective to combine compound statements, a simple statement to form compound statement. Now, let's look at some definitions. Let's look at some compound statements, okay? So many mathematical statements are constructed by combining one or more propositions. For example, look at it, John is smart, or he studies every night. What are the statements you can see in this particular compound statement? What are the simplest statements you can see? Yes.
Sir, smart and steady.
Smart and steady. Those are not statements. Smart is a keyword. Steady is a smart is an adjective, and steady is a verb.
Sir, smart.
So
John
you
is
see,
John
you
is
see,
smart.
okay. So this one, John is smart. John studies every night. I
Yes,
hope
sir.
you can see that.
Yes,
So
sir.
these are two simpler statements that are combined with Boolean connectives to form a compound statement. Which connective that combine the two statements together in this case? Or, very good. So the connective or, this one, okay, that combine the simplest statement into compound statements. And these connective are also called logical operators, okay? Another word for it is logical operators. All right. So let's look at some connectives here. What are the connectives you see here? What are the operational logical signs you see here?
Not.
Not. A lady?
And.
And.
Or.
XO.
Okay.
Implies and
then if.
Okay. No, the imply is the if, okay? The other one you see is if and only if. If and only if. So, not is for a unary statement. Not is a negating operator. For example, John is smart. It's a simple statement, isn't it?
Yes.
Yes,
So
sir.
if you negate that statement, what does it mean?
John is not smart.
John is not smart. Good. Is that Abdul was you?
Yes.
Good. John is not smart. So the symbolic for not operator or the negation operator is either this or tilde. Have you seen a tilde?
Yes.
Yes, sir.
So you either see angle or tilde. Tilde is like this, okay? Or angle. So these are keywords. So John is smart. The negation John is not smart. Abdul Wasil is a member of the class. When we negate that, Abdul, what will be the negation?
Abdul Wasil is not a member of the class.
Beautiful.
Class.
John Dramani Mahama is the president of Ghana. When you negate it, what will it be?
John Dramani Mahama is
Dramani
not
is not
president of Ghana.
Okay. So you realize that if you use the word P, let's say use the letter P, and the letter P denotes I am a girl. If I negate P, it denotes what will it be?
I'm not a girl.
I'm not a
I'm
girl.
not a girl. Good. I'm not a girl. So that is the youthfulness of negation. I hope that is clear.
Yeah.
Now the next operator is the AND operator. AND operator is a binary operator. Binary operator means it can combine two statements together, or one compound statement and another set of compound statement together, or two simple statements together, or a compound statement and a simple statement can be combined together using the words AND. So when I say binary, you are going to give me two statements. A lady will give one, and but she'll be very simple and short statement. And a guy will give one. So he is equal to her. Who is going to give one? Abet. Abet Ajay.
Kofi is a girl, and Amma is a boy. Kofi is a girl. Kofi is a boy,
No,
and Amma is a
just
girl.
mention one. Kofi is
A boy, and
a
Amma is a
boy.
girl. And Amma is a
So
girl.
that is one statement. Now, just give you one simple statement.
Okay,
Then a
Kofi
lady
is
should give me another simple statement.
so the dog and the boys are playing.
Just one simple statement. Don't combine those. Combine the statement. So the dog is playing, right?
yes, sir.
Yes.
Rosalie like playing. The dog is.
Rosie.
The dog is playing. All right. So a lady should give me a statement like this. What will this statement be? P and Q. Okay, so there are a lot of hands up. Let's see the hands that are up. Akufo, Abdul, P and Q. Akufo, please unmute yourself and talk. Okay, so Jikunu, Akufo is not talking. Jikunu, please talk. Right, Justice Jikunu.
Okay, sir. So the answer is Kofi is a boy and the dog is playing.
Okay, good. So you see the statement here. There are two simple statements that are combined with AND operator. The AND operator in logic is called conjunction operator. Okay, the conjunction operator. I will use this angle, downwards angle here, as conjunction operator. So this P conjunction Q means that Kofi is a boy and the dog is playing. I hope that is clear.
Yes, sir.
Yes,
All right. Now the next operator to use is called the disjunction operator or OR operator. And this OR operator is called inclusive OR. Inclusive OR. So the OR operator is called inclusive OR. So what it means is, if I should write this P disjunction Q, another lady in the class will tell me what that could mean in simple English.
Yes, yeah.
How many ladies are in the class?
Yeah.
Oh, even if you are a guy, you change your voice to be a lady, unfortunately, you can't be you. Your voice has betrayed you. Okay, so Abdul, please give me the response.
Kofi is a boy or the dog is playing.
Okay, Kofi is a boy or the dog is playing. So this is an OR operator. Is that okay? Then we have another operator, very good, very important operator. XOR, that's exclusive OR operator. XOR. And you see the symbol XOR simply means that Q or P or Q, but not both. Okay, what all means either one or the other or both. But XOR means either P or Q, but not both. So that's as the intersection is 0. Okay. All right. Then another operator to look at. Yes, please.
I'm sorry, my line went off. Earlier, I wanted to answer a question, but now I see we've gone past the end side.
Okay, so what's the problem?
Okay, so from where we started, the end, I didn't really get it. That's why I had wanted to answer the previous question to see if it's in line with what I was thinking.
And you just using the word "and" to combine the statement. Okay.
Okay,
Kofi
sir.
is a boy, and the dog is playing. So you have used "and" to combine the statements. So you put the two statements together, but join them together with the operator called "and." Just as we do in mathematics, 1 plus 1, we use operators like addition, multiplication, subtraction, division, of to operate on numbers, right? Instead, we use operators like union, intersection, what's the name? And many more. Complements. All these operators in sets. But in logic, the same thing, but we use operations like not as in negation, operations like "and" to operate on statements.
Okay, sir.
Okay. Then we use operators like or. So or is actually the inclusive or. So we're talking of either Kofi or the dog. Okay, and both. But when we talk of X all, it's either Kofi or the dog, but not both. Is that clear?
Yes, sir.
All right. Then the next one to talk about is implication operator. Implication operator talks about the condition necessary but not sufficient for fulfilling the consequences. There's going to be precedence and conclusion. So based on what the conclusion is drawn, if asks the other, I hope that is okay. You understand that? If, so it means that there's going to be a premises, there's going to be a condition for which conclusion is drawn. So that is the implication operator. Then we have biconditional operator, which is if and only if. If and only if is just like implication, but more stronger conditions. For example, I'm sure you heard some years ago when this famous statement became so political issue. If the fundamentals are weak, the exchange rate will give you up. You heard of that statement before, right?
Yes, sir. Yes, sir.
So that is an if statement, okay? If the fundamentals are weak, then the conclusion exchange rate will give you up. So when the table turns and the question is asked, now exchange rate is giving you up, does it mean the fundamentals are weak? The answer is no. Did you hear that statement too?
Yes.
The answer was no. The reason is this: the condition for exchange rate to give you up is the fundamental be weak, but not sufficiently. So that's the word if. But if the statement could be if and only if, it means that if the exchange rate is giving out, it also implies that the fundamentals are also weak. So that becomes a biconditional statement. But because it's just an implication statement or a conditional statement, there's a route of escape when the fundamentals are giving you up. You conclude that it's not because the exchange rates are weak. It's not because when the fundamentals, the exchange rate is giving you up, you conclude that it's not because the fundamentals are weak. And that is truly a logical conclusion. I hope that is clear.
Yes, sir.
Any question? Any question? Right.
My question is, can you give us an example of implication operator?
Okay. Who are the ladies in the class? The ladies who raise their hand. Gifty. Okay. If Gifty comes to campus, then she will see me. Did you hear that statement? How many statements have I combined together? Gifty.
2 statements.
Gifty, how many statements did I combine?
2, please.
What are they? What are the simple statements in that compound statement?
If I come to campus and then
Okay.
see you.
If Gifty comes to campus, Gifty will see the lecturer. Okay. All right. Now look at this statement. If then, that is the implication statement. Okay. Now the question is, if it is true that Gifty comes to campus and Gifty sees me, the statement is true. The compound statement is true, isn't it?
Yes, sir.
If it is true that Gifty comes to the campus, but Gifty did not see me, what do you say about that statement?
It is false.
It's false. The compound statement is false. But if it is false that Gifty comes to campus and Gifty saw me, what is that statement? What is the logic conclusion about that statement?
It is true.
It's true? She did not come to campus and she see me. It's true.
No.
It's false.
It's false.
No, it should be true. What about if she didn't come to campus, she see me outside campus?
It's true.
It's true, right? So you realize that the statement is only false if she comes to campus and she did not see me. And if she doesn't come to campus, she doesn't see me, there's nothing wrong with the statement. Although the statement is valid. I hope that is clear. So the implication statement, if the first statement, then the second statement. I hope that is clear. If then, okay. But if you see a statement like if and only if Gifty comes to campus, then Gifty will see me. That statement is different from if Gifty comes to campus, Gifty will see me. I hope you understand the logic. All right. All right. So, any question? Hello, any question? Moses Yebua, it's just a wise thing to do to mute yourself when you are having online lecture and you don't want to talk to us. Other than that, you'll be saying something that are not really good for us to hear. Bearing in mind that I'm recording the lessons. It doesn't mind. Class, thank you very much. Anything else, please? Any other question? Any question? All right, if there's no question, we'll bring the class to a close. Thank you for coming. We'll continue online lecture next week. Sorry, class rep, read the messages in the chat to see whether there's time to respond to.
Okay, sure. All right, so I read right now. I'm back to them.
Can you do what?
I'm in a pattern right now.